Okay, we want to use the midpoint rule to estimate the area for this exact same function. So we're going to do kind of hopefully the average between the two. Once with 2 rectangles and again with 4 rectangles. Okay, with the midpoint rule, how we're going to draw that or how that works is again, one time we're going to do with 2 rectangles, so that means the length of each of these 2 rectangles has got to be, I wrote a 1, that's got to be a 2, I've got them backwards here, and then this one down here has got to be the 1. So if you're going to divide a total width of 4 into 2 equal pieces, obviously it's 2 and 2, and then for the 4 rectangles, each of those have got to be a length of 1. Divide each the total width of 4 from -2 to 2 into 4 equal parts, it's going to be by 1. Okay. So now how to draw the midpoint. What we're going to do is that basically you consider what's the midpoint between 0 and 1. Well, it's right there at half. So we're going to take a half and we're going to go up until we touch our graph, and that right there is what's going to form our first rectangle. Go to 1 1/2, go up until you touch your graph, and that right there is what's going to form the rectangle. So you can see that half of your rectangles are going to be inside your function, and half of your rectangles are going to be outside. So let's do the same thing on the left. Go to -1/2. And we're going to go up until we hit our graph, and that's going to be the rectangle right there. And then go to -3/2 or -1.5 and go up until you hit your graph, and that's going to be the rectangle right there. Okay, so we've had basically our x values now that we're going up to touch with are 0.5, they are 1.5, -0.5, and -1.5. And that's what we're going to be plugging into our values specifically when we're looking to find the height of each of the rectangles. So obviously, since I accidentally started with the 4 equal rectangles, I'm going to go part B, or the second one first, where we want to find the midpoint rule with 4 rectangles. So the area in this case will be height of the first rectangle, which is plugging -1 1/2 into our equation. And that's going to give us then a height of 1.75. So that times 1. And then the midpoint of our second interval is at -1/2. So when I plug -1/2 into our equation, we'll get 3.75 and then times 1. Okay. The midpoint, or the x value that we're using in our third rectangle to get the height, is 1/2. And when we plug that into our equation, we're going to do the exact same thing. So 3.75 times 1, and then the last one we'll get the 1.75 times 1. So when we add all this up together, we're going to get an overall area of 11. Okay, so now let me erase this graph real quick. Let me show you what it's going to look like for 2 rectangles, and then we're going to see what kind of area we can get with that one. Okay, so when we have 2 rectangles, we have one base just going from 0 to 2. We have another base going basically from 0 back to -2, and so the midpoints are going to happen at 1 and -1. So if I take each of those midpoints and I go up until I touch my graph, that right there is representing the rectangle for that one. Take this midpoint and go up until I touch my graph, and that's going to represent the rectangle for the other one. So what are the heights? Well, the heights are going to occur whenever we plug in basically 1 and -1 into our equation, because the widths down there are definitely by 2. There's 1, 2, 1, and 2. So the area is going to be the height when I plug in 1. So 4 minus the 1 squared will be 3. So 3 times 2 plus 3 times 2 is going to give me an overall area of 12. So compared to what we did before, look how close these two answers even are. They're 12 and 11. Whereas when I go back before and I was at least checking the upper sum, they're somewhat close, but they were 16 and 14, but it looks like we're getting a better idea estimate of the area. Okay, so before I go on, let me just do a general summary just real quick. On how to get a lower sum, what you want to do is you want to, let's go with that, we'll say that's 4. Let's say I have 4 equal parts. Let's just focus on the 4 so that we get answers. You're going to always start at your interval and go up until you hit the graph. Start there and go up until you hit the graph. Okay? And then go up and hit the graph, and then go up and hit the graph. So with a lower sum, once you hit, you've got to stay within. And obviously within would be right in there and right in there. Okay? And then to get your height, you just take those values like -1 and 1, and you plug them into your equation. Okay? So lower sum, you start at your interval, at your points, and stay within the function. Now with the upper sum, okay, you start there and you go out. Okay, I'll probably start here on the inside. You go in and you go up, then you go over. You stay in, you go up, and you go over. You stay in, you go up, and you go over. Go up and go over. Okay, so when we want to get these heights, then really what you're plugging in is the maximum value, which we're going to go outside. So you don't want to plug 1 in, because 1's actually going to give you the height of this one. So the height of that one will give you that 3. The height of this one, as you can see, is going to go up to 4, so we're going to plug in 0. The height of this one, we're going to plug in -1. Is 0, you get the 4, and then -1 to get the 3 right there. So lower sums, you stay in. Outside, the upper sums, you stay without, or you stay outside. And then for the midpoint sums, remember, we're going to choose those values just like what we did in between. And then you just go up until you touch the graph, and part of your rectangle is going to go out and part's going to go in.